Hi, and welcome to today's presentation, Avoid Unplanned IT Outages with IBM's Cognitive Machine Learning. My name is Jay Ward, Business Development and Marketing Lead here at AccuOSS, and here shortly you'll hear from Rodney Rendles, Managing Partner and Performance Specialist at AccuOSS. And today we'll be walking you through IBM's Predictive Insights. And what that is a machine learning tool designed for IT operations to give IT operations the ability to consume performance metrics, really any kind of time series metrics across the organization in different sources, into a single place and start doing behavior analysis and learning on that, on those metrics. So that way you can start to see things that become anomalous in the environment and alert on anomalies as they occur in real time. So with that being said, I'm going to go ahead and move to a quick introduction of AccuOSS before we get into the presentation. Accurate Operational Support Systems, or AccuOSS, is an IBM Premier Business Partner. We provide value-added services like advisory, integration, and development services for the operational support systems and IT service management solution stacks. Typically, we work with customers in the communications service provider, E&U, and the financial services space. And with that being said, I'm going to go ahead and kick things off to Rodney Rendles, Performance Architect here at AccuOSS. Thank you.
Everyone has problems, and we like to say that with the analytics platform, we can help expose some of those problems that aren't currently, driving a lot of the smaller minutia type things that are going through the millions of pieces of data that people see. So IT operations with big data is quite a challenge. I mean, most large enterprises today have thousands and thousands of servers, network devices, storage mediums, middleware, and not to mention the stuff that they're placing now in cloud and having hybrid type environments. Large ISP, MSPs with 20 to 30,000 servers, generating many terabytes of log data per day or performance data on a daily basis. And now a lot of the more adaptive DevOps and agile type development that is pushing platforms to production sooner and faster, oftentimes don't have the soak time that they need for some of the quality assurance. And so what we see is a lot of these challenges are going into the organization, but the exposure to the insight into those problems is becoming harder and harder to detect and to analyze, using our traditional, capture performance metric, threshold on a metric when it reaches a certain type of threshold. And then usually by the time you've reached that burst, you're already into a point where you're either losing business, losing resources, or losing customers. So the traditional architectures out there, and this is what we see as a pretty standard OSS or ITSM play in the OSS cycle, where you have a change management database kind of sitting in the middle, and you have all of your resources being discovered and collected, and then some configuration management probably going on those, with your traditional log monitoring and event monitoring kind of going on and feeding somewhat of a proactive plan back up to the network operations center or to the folks watching the environments to ensure that they have some insight. The challenge here is in the traditional sense is we usually capture the wrong thing, usually too late, and we spend a lot of time sitting on conference calls and meetings trying to determine what the real root cause is of a particular problem, or even not even having introspection into a particular segment of the problem that might be critical to solving it sooner, faster, and detecting it. And in the traditional approach to prevent outages, usually you have to have service models configured, you have to have a CMDB that's fairly up to date. All of your physical and logical entities usually need to be mapped to over the top of those processes. We go through the challenges of maintaining and keeping up to date all of this infrastructure to support the visibility aspects of being able to quickly resolve a problem when it occurs. And there's a lot of resource time, a lot of even just managing thresholds in a lot of environments takes, man hours or man weeks per month to even keep up with. A lot of the smaller things that are going on are not even detected by traditional monitoring or by the traditional performance counters that are being tracked and measured, especially when you go to something like a multivariate analysis where you are trying to look for anomalies that might be occurring across multiple metric perspectives or multiple resources. And the unstructured data that we get in from logs and from performance data is often, it takes a lot of extra time to have, analysts sit through, grepping through logs or looking through plots to try to figure out, what might have happened, and even when it all works, we still feel like it's sometimes difficult to trust the analysis that is being done. So the challenges that we see of, obtaining insight from all this data is, if you are maintaining a CMDB or you are maintaining the resources to track all this stuff, it does take a lot of structure, time, and management to really keep up with all the CIs, their relationships, their service mappings. And, when you do have all those CIs in place, really do you have the monitoring infrastructure in place to really instrument all of the tracking and monitoring of those particular things, and really being able to analyze that stuff closer to real time versus, some batch processing that might be occurring at nighttime or on a more ad hoc type basis to try to determine if there's a status of an outage or some kind of status of the health of the device. And when you do find a resource is bad, impaired, or anomalous, how do you know that it's really bad, impaired, or anomalous? It could be a normal cutover occurred where traffic spikes on one particular circuit because another circuit did a failover. And while that's interesting, it's not necessarily anomalous, where traditional thresholding would probably throw some type of anomaly for that occurring. It may be completely normal to the situation currently occurring. And so we typically find people have a lot of correlation chaos, dashboard demise, what we call the sea of red with the event flows coming through, SLA disagreements with whether or not things are in or out of agreement for their SLAs, and scorecard slumps, where we really feel like the values going into a lot of those are best guesses and really aren't aligned to what's really occurring from a mathematical perspective. So really with all of these things that we've implemented and orchestrated throughout the years to try to get all of these things in place, I mean, how can we still have an architecture that could still have some chaotic activity? Well, what we found is, a field of study in the mathematics that studies the behavior of dynamic systems that are highly sensitive to initial conditions. So a pretty traditional butterfly effect. A small downstream thing might cause other things mathematically going up the chain, where it could be a simple DNS change, or it could be a simple configuration change on maybe the number of allowed sectors for something, or the number of allowed memory buffers for an application. And really in testing, nothing was detected as anomalous and everything seemed good for rollout. But once you roll it out to your production environment, all of a sudden a small issue can start to grow and really cause some chaos in the overall determination of what was going on. So oftentimes identifying anomalies that are what we call kind of a micro anomaly on a univariate perspective, we're constantly testing for performance metrics that are tracking away from their normal. And traditional performance monitoring, you're probably going to run into something like a 95th percentile calculation or a hard burst threshold calculation that is set on your performance metrics. But what we're looking for in an analytic perspective goes well beyond that, where we're looking for things that are not normal to their normal behavior. And I think that is really where we get into trying to figure out early warning. So we like to use the storm analogy for this, where even, hours before a storm really hits, you have maybe a little bit of wind, maybe some light rain is starting somewhere. You might have some skies darkening up, and things might feel a little different. And these are all warning signs that something could be coming. Well, we found that mathematically, your services typically have very similar type early symptoms that can indicate things like that. Something starts to deviate from its standard by a little bit, or two resources that normally track well together start to deviate from each other. You wouldn't notice these with traditional thresholds because nothing is being violated yet, and you are really on the path to something occurring, even though you haven't reached that perfect storm where everything bursts and all your events flow in for your performance analysis thresholds getting passed. And so really, we don't say that this is a replacement for traditional performance management. Really, it's something to work in augmentation of that, where at some point, if people feel like they can turn off their traditional burst thresholding, we think that's great. But our initial pass at this stuff, and what we're really looking to try to help people solve, is all of the small, minute anomalies that might be occurring either in a multivariate or univariate perspective, so across resources and metrics, or with each individual resource and metric. So we find that a lot of these meltdowns are hard to detect. Why? Because we're dealing with, typically on large organizations, millions and millions of health metrics that all have some hidden symptoms within them. And today we're going to focus mostly on the top box, which is really doing performance analysis data. But in kind, we also have a secondary path for doing monitoring of the terabytes of log data to look for interesting or hidden things that you couldn't look through manually as efficiently to try to find, and try to be more proactive about that. And that's the IBM log analysis tool. But today we're focusing on the top box, which is really the Predictive Insights tool. So with all of this data, what our goal here is to find these problems and diagnose some type of anomalies before things completely get to a meltdown point. So what do we consider the solution to this particular problem? Well, we need to find a way to shift. So we want to try to detect the issues early, find our root causes early, and restore service or augment the service before the customers notice any kind of serious impact. And so we typically want to move, which you typically might find, a problem occurring early in the morning, maybe by 9 or 10, you realize that you have some kind of a business impact. And at that point, you're in a reactive state to try to restore service, or to try to get somebody looking at it in an emergency basis to try to make sure that service is back online and working. Well, with anomaly detection, we can actually start right back at the very beginning of time when the thing started to go anomalous. We can detect it within a few minutes of it moving into a standard deviation that's kind of off. Look for any multivariate analysis that might be going on with it, and then try to do some type of proactive restoration, before we reach that critical business impact point. And so, again, what we're going to discuss today is the light blue box in the bottom, and a little bit of the green box on the end here. So that I'm going to jump into the demo. And what we've set up is we have 5 scenarios of where doing anomaly detection has helped us avoid these unplanned IT outages and really look for data that is interesting to what could be a root cause of a problem going on. So the first scenario we're covering is a univariate scenario, so it's on a single KPI on a single resource. And what this particular scenario will walk us through is a denial of service attack that is currently that was going on at this particular customer in the sense. So what we've done is we've detected that there was more traffic than usual on many of the network links in this particular organization. But on a univariate perspective, the links had, there were like 10 gigabyte links, so they had plenty of capacity for handling all the new traffic coming in. But the challenge was that because of all of this new traffic that was coming on, it was such a light growth curve for the particular metric that they were looking at. It wouldn't have been something you would have detected with the traditional performance monitoring probably until you've consumed the majority of the capacity of that particular link before and maybe at that point you're already starting to affect customer traffic. So what PI was able to do in this particular case, and we'll drop into the anomaly here, which is this guy here, and those of you who are Omnibus users will notice that this is a normal Omnibus event screen. So the anomalies that are detected get thrown into Netcool Omnibus just as a traditional SNMP trap or syslog event would. So you can also utilize all of your standard correlation and automation and enrichment things that you're already using for other types of events. And in this particular case, what the anomaly told us is that this particular link has bytes that are higher than expected, and it has some mathematical calculation it did. Now we can right click on this particular event just like you can with any of the Omnibus right click tools, and we can launch right into a service diagnosis on this particular anomaly. And what we see is this link goes through pretty standard patterns of medium traffic throughout the day, but it does stay within a fairly decent range. And so the baseline deviation that Predictive Insights calculated for this gives you quite a bit of headroom for looking for problems. But at this particular day, we can see here at the end of the day, all of a sudden this link started slowly rising and slowly rising and slowly rising until we got to where we consider to be out of standard deviation. And as soon as this occurred, we threw an event. Now, if you look at the growth curve of this thing, it still took a while to notice the increase, but this thing only went from a few percentage of utilization more than it was pretty normal for it to do. And so using traditional thresholding, they probably not would have seen this occurring for another week or so, because they had up to 10 gigs of available or a gigabyte of available bandwidth on this particular link. But we did notice the rise increasing and occurring in a way that looked anomalous to the system. So what it said here is, at this point in time, I'm going to throw an anomaly and then track, from then on what the thing did. And so as soon as it found that, it threw an event into Omnibus saying, hey, somebody might want to come look at me. Well, one of the things we noticed on this was because of this increase in traffic, they went back and started looking at it, and they actually caused the denial of service attack to themselves by doing a configuration change that forced some cross-link to occur on some other stuff, and things were kind of sending additional packets back and forth, and it just kept compounding, and they were kind of in a bad storm of traffic that they were causing on their own. So once they made the configuration fix, their traffic leveled back out, and they were able to get out of the anomaly. But again, that could have gone on for, according to the customer, they probably wouldn't have noticed that their traditional performance management for probably a few more weeks before they would have hit their burst thresholds. And so that, this is one example of a univariate where we're able to catch it within a short amount of time versus potentially the long time that it would take to do traditional performance analysis. So I'm going to drop back out to our second scenario. And our second scenario is also a univariate, so it's a single resource. And in this particular case, we noticed that, we were having a database that was behaving quite unexpectedly to its standard norms. The connection pool for the customers normally went through a process where you see a rise and a fall in the values throughout the day. And one of the interesting things that Predictive Insights can do that most other platforms have some challenge with is determining that, something, even though it's within standard deviation and normal, it's not acting behaviorally like it did previously. So in this particular case, and we'll hop into this one and take a look. what we have for this particular scenario is a normal rise and fall of the traffic pattern throughout the day, and you probably have kind of normal traffic occurring based upon usage of this particular service. Well, when we caught this anomaly, the thing that's interesting about this one is we didn't go outside of standard deviation. So the green baseline is pretty normal. Had we have gone out of that, we would have also thrown an anomaly for being out of deviation. But in this particular case, what the anomaly is telling us is that we've flatlined. We are no longer variant where we used to have variance in our metric. And this one's pretty important because what ended up happening on this particular one is we hit a maximum buffer that couldn't grow anymore. So a misconfiguration on this particular database connection pool, it peaked out. And when it peaked out at the 3200, it stayed there for a period of time to where the system determined, hey, this thing is no longer varying like it should have. And by doing that, the predictive insight system is able to say, we know that this thing is constantly, every time we get a sample from it, it is varying to some degree. But now we flatlined. And since we're flatlining, we're going to go ahead and throw an anomaly, showing that not only, did this occur, but we're estimating in our forecasting, the dotted lines at the end here are forecast, that this isn't going to get any better. It's happened long enough now, and it's been at the same state long enough that we're pretty sure that there's something that somebody needs to look at here. And so in this particular case, they were able to go in and take a look at their connection pool size and determine that they did have a hard max, that once they were able to correct it, they were able to get themselves out of their connection pool size challenge. And this thing started, if you kind of look at the time frame at the bottom, at 5 a.m., it kind of started rising on them. By 6 a.m., they hit their max. And so within an hour of this particular anomaly occurring, or this rise to anomaly, we were able to detect and throw an event to the NOC to be proactive about getting a DBA to take a look at this connection pool issue. Where again, maybe something like a traditional monitoring wouldn't have had a threshold set, or you would have to set a perfect threshold to know that when you're reaching that particular maximum. The system was able to automatically compute that just through the mathematical standard. So that is a good example of having something within standard deviation, but is also still anomalous. And so we'll hop out here to our third scenario. So the third scenario, again, being a univariate, so a single KPI. What we're looking for here is the event priority and forecast. So this is more of a metric that shows response time, and just to kind of go more into the forecasting capability of the predictive insights tool to kind of set a priority for yourself on, what is this important enough for me to look at or not? So by determining, this particular response time on this particular workflow started increasing, we had a couple of little things where it just barely touched its peak, and so it should have gotten a couple of anomalies here. But then here, the real challenge is when it rose above this particular area, it also stayed there. And so we know that it's been in this particular period for at least 4 hours and 45 minutes. It computes it down here for you. And the important thing for this particular KPI is we wanted to show that the forecasting shows that it's not going to get any better. And it's going to continue to trend up, and we expect it by 9 a.m. that it's going to reach somewhere in the 9,000 range, where a normal behavior for this particular app is sometimes like 10 times smaller than that. So you're going to have users with long wait times potentially waiting for this particular service to run or load or show results for it. And again, with traditional monitoring, you might be able to catch some of these response times with burst thresholding, but what you don't get is obviously some of the instant forecasting of the mathematical models to determine that, in some cases we see downtrends in KPIs, which are interesting, where it rises up, but the system does expect it to come back down because it's seen it do it before. But in this particular case, it's a new problem, and the system is computing that it's going to keep tracking on the northbound side and continuing to go up. So not that interesting of a metric KPI, but it does show the system's ability to mathematically compute beyond your current time window, so you can get a feel: is this something I got to look at now, or is this something I can come back and address, in a few hours, since it's not necessarily critical. So you can use it for helping your NOC engineers or your tier 2 guys, tier 3 guys determine if it's something that they need to look at today, or is it something that we can put off on the back burner for a period of time. And so that's kind of all of the univariates that I currently have to show. And probably the more interesting ones, though, however, all these multivariates. And the multivariates being quite a bit more interesting from the sense of there is no CMDB backing the service models. There is no relationships having to be maintained. The system is computing all of this from a mathematical relationship between KPIs that are doing interesting things at the same time together. So what Predictive Insights does under the covers is it automatically builds these relationships between the metrics and what normal is for those metrics as they track to each other. And when things go abnormal, it also takes a look at those relationships to see whether or not all of the particular relationships are working in a similar abnormal fashion. And what it does, it gives us the opportunity to put those together into one view, so we can kind of get a feel for what might be potentially going on across those. So in this particular case, we're going to look at this one here, which is a related event that's a consolidation on 2 different metrics that occurred. And you can jump in and look at child alarms. And so you can look at the 2 original events that make up, or the 2 univariate events that would normally make up that particular group. Or you can just plot directly from the multivariate right to the service diagnosis to show both metrics at the same time, which is often more interesting. And so what we got here is we have a SAN where we've got 2 resources, the SCSI disk A and this LUN disk 7. One is getting a pull hit ratio degradation, and one is getting a response time anomaly, both at the same time. And so the system has determined over their pattern of life that these things do have some type of interesting relationship. Because as you can see here, every time one goes down, the other one goes up. So every time we have a pull hit ratio that is dropping, we also see that our response time on the other particular LUN is going up. And it's not something that's happened just once in this particular case. It's happened several times. So the system is knowing to start tracking these particular KPIs together as a relationship. And we can turn on a baseline for one of them and kind of get a feel for where that particular metric normally would have its baseline calculations for. But again, here, later on, we had another crossing where, again, what we see as this one is going down, this one is going up. And so every time we see pull hit ratios decreasing, we see response time increasing. And vice versa when they come out of that situation. And they reverse back to kind of a normal standard. And in this particular case, when it hit the final kind of large problem anomaly here, both of these particular things were out of their deviation in a way where the system said, okay, this is going to be something we need to throw an event on. And, this particular one, it stayed in that situation for about an hour and 5 minutes, it looks like. And normally, they would have been looking at just one performance metric, or people would be looking at one performance metric for maybe, the SCSI disk that's sitting on the physical server or the logical server. And not really looking at the SAN LUNs that are supporting that. But by being able to draw the correlation between the mathematical correlation that these things occur at the same time, we're able to really draw a conclusionary anomaly that these two are related and they do affect each other. And it gives you a pretty pinpoint thing to look at one or the other as potentially being the root cause of what might be driving this anomalous behavior. So the mean time to detect and the mean time to repair typically go down when you can draw these kind of correlations and get people looking at the right thing sooner, versus kind of running around and figuring out what is linked to what from a CMDB or a service model perspective. Nothing was fed into this particular system to give it any kind of hint that these two things are related. Every metric is associated with every other metric and in an analysis perspective to determine if the two do have any relationship, and if those two have relationships, are they something that when one does go anomalous, the other one always goes anomalous with it. And so this is a good example of the power of PI's multivariate analysis, which very few tools in the market really work across. I think there are quite a few tools that are good at single variate metrics, but I think when you get into the univariate experience, you really are finding more interesting things than you could find with traditional performance or traditional even analytic tools in the market. And so I think that this is in this particular case, I'm trying to think of I think the root cause of this one might have been a misconfiguration on an HBA, and they ended up correcting it on the SAN side and fixed the anomalous behavior. But just like with the univariates, we can turn on potentially, the forecast metrics for these, and say, if you wanted to turn them on, I think it might draw them. I'm not sure if my screen's wide enough or not, though. Here. Yeah. So again, with the, it doesn't look like it's going to be coming outside of the anomalous state anytime soon, since they're both kind of tracking still in the lower ranges, and it expects that it's going to be in that same anomalous behavior for at least another couple of hours based upon the mathematical prediction. So it is probably something worth somebody taking a look at pretty quickly, so you can stop your users from experiencing maybe potentially slow applications or slow response times from their server, or from things going on that this particular set of disks and LUNs are associated with. So I'll go ahead and drop into our fifth scenario, which is again a multivariate, and we are looking at automatic grouping. And so as I alluded to earlier, things do get automatically grouped when they're similar. And one of the nice parts about this are you're not dealing with all of the univariate analysis. Like if you take a traditional performance management platform where maybe you did catch some of these counters going anomalous just with your traditional thresholding, you probably got 5, 6, 8 alarms in your event management system that really you'd have to go into a secondary system and build some type of correlation to say, whenever I see this and this occurring together, I want to suppress these events and create one situational event or one synthetic event that might help my NOC understand of what was really the root cause of this particular thing, or what is potentially something going on across these multiple events occurring. So one of the nice parts about PI is that it does that out of the box with all of its anomaly detection. If it does find something that is correlated across nodes, it does have the ability to suppress the events in a way that from a view perspective, you're not dealing with all of the multiple metrics. And this is probably one of the more interesting scenario cases, because what we have here is we've got a set of resources that are the BOCNT processor and the ALMNT processor, and we're tracking user time and processor time for this particular process. And as you can see, historically, even though they're on two different physical servers, these things track pretty dang close to each other all the time. I mean, they're almost always in sync with what their metrics are. Now we can turn on the baseline again for any one of the metrics. And we can see that while they deviate some from each other from a baseline perspective, really, whenever something is happening to one, we always see that something is happening with the other ones. And so we know mathematically that those things are absolutely related. There was no CMDB here or any type of helper information or enrichment given to the data to tell it that these things are similar. It was completely computed. The relationships and the grouping is completely computed by the PI system to understand that, it doesn't necessarily know what these things are, but it does know that because they are mathematically similar, they will always track together. And when they go deviant, and they have some kind of deviation, they're also kind of partially doing that together. So this user time really dropped below its baseline. But all of the other ones are also on a small downward sweep. And the icons on this particular GUI show you that, it is anomalous because it's gone outside of its expected normal values. And all four of these metrics did that at the same time. And even though this is the only one outside of its standard deviation, it knows that the other ones are still tracking individually on their own deviations the similar way. But it was able to group them in a way that we know that definitely there is something that is correlated between these particular resources. And we also have another anomaly here that it didn't highlight or group into the grouping for the event, because it can't guarantee that this anomaly is necessarily affected the same way, but it does notice that this same anomaly down here, this processor time on this third server now, is also showing some anomalous behavior where it is actually down by the similar kind of deviation that the other ones are. And it just so happens that it's also that same type of process running on a similar kind of server. And you could turn that KP on and look and see how it plots with the rest of them. And so while it's technically down, it does rise and fall differently than the other ones do in a different pattern. So PI said, hey, this might be something you want to look at, but we're not going to guarantee that it's necessarily part of this particular anomaly occurring. But it is nice that it gives it to you in a way that lets you turn that on and off if you choose to kind of see if it's correlated. From a human perspective, where oftentimes we know from tribal knowledge some of the things you can't compute with the mathematics. But again, I think this being one of the more interesting potential metrics because of the way that the things are tracking, and how does PI really do that from a multivariate perspective? I get asked quite a lot, and what it comes down to is PI has an engine under the covers that allows it to normalize all of the metric data to a similar mathematical pattern. So you can actually put a percent in against an octet counter against a state counter, and PI will normalize all of those into a similar mathematical range where it can start tracking those standard deviations and detection of anomalies based upon not only their actual values, but their normalized values and their normalized values. And we do have the ability to look at both of those in this particular UI, where if currently we're looking at the normalization in a normalized view, we could look at the absolute values of those particular counters. And in this particular case, the absolute values are pretty similar because they're a similar type metric. But in a lot of scenarios, you could be looking at something where you've got like you said, maybe it's a ratio counter or a ratio against a counter against a state, and it really can cast all of those into a similar normalized thing. So you can view the data in a normalized way where you're not looking at a range of values on a particular plot that you get hidden in the minutia of the larger counter when you plot them together, because one is several million and one might be in the hundreds as far as our current metric, and that's kind of hard to view when one forces the other one to almost be collapsed into a non-visible state. So by normalizing the counters, it even gives you a better visual representation of how the metrics trend together and track together. Because you can get into scenarios where your absolute values are just way off of the plot's scale in order to being able to see those things in a normal kind of way. So those are the 5 scenarios I have to go through. I wanted to leave some time at the end of the call here for questions. And so Jay, if you want to, I don't know if you received any throughout the presentation or not, but we can field questions now if you want.
Okay. Well, also, if you do have a question that comes up after the event, I think you have my email address, so feel free to send over your question to me directly, and I'll go ahead and get that responded for you or answered for you. I'm also going to send out a survey to everybody who registered, and just if you could take a minute to respond to that survey. Would love to get your input on how well we did. And I just want to say from AccuOSS, thank you so much for your time today. Hope you enjoyed the pizza, and hope to talk to you guys again. Thank you.